So this is worksheet 2. We're going to go through the answers for data tables and graphing. In this first problem, we've got data that Annie collected about her teammates on the basketball team, and how many games that they played, and then what their free throw percentage is. And so what we're trying to create is a data table that organizes all of this data. And so what we need to determine first is what the independent variable is and what the dependent variable is, because the independent variable has to go on the left side of our graph. So the independent variable, the thing that changes purposefully and has an effect on the dependent variable, would in this case be the number of games that each player plays. And the dependent variable would be the thing that changes as a result of how many games each player has played. And so as players play more or less games, their free throw percentage changes as a result. So then once we have the left column and the right column determined, then what we can do is we can take this data and we can organize it usually by smallest to greatest in the independent column. So you'll see that for the number of games, we organized it from 3 all the way up to 28 games, which are the minimum and maximum number of games played. And then we just put the percentage that corresponds with each number in the same row. This data then can go onto the graph. And so in making a graph, we're going to write down our acronym, TAIL. And TAIL stands for title, axes, intervals, and labels. And so the title for this is going to be the independent variable and the dependent variable, and having some kind of relationship between them. So you'll see that here we said it's the effect of game experience, or the effect of the number of games a player plays on their free throw percentage, showing that we've got the independent and the dependent variables right here. Game experience. Then for axes, we have to make sure that we put the independent variable on the bottom of the graph and the dependent variable on the side of the graph. And so number of games has to go down here, and then free throw percentages have to go up along the side. And now we've got to try to find intervals, and intervals are the most involved part of this. For intervals, we have to first see what the largest number of games played is. So if we look in this table, the largest number is 28. And then we have to count how many spaces we have. So we've got 1 space, 2 spaces, 3, 4, 5, 6, 7, 8, 9, 10. So there are 10 spaces, meaning we can take this maximum number that we need to go on that axis and divide it by the number of spaces, which is 10. Then we get 2.8. And 2.8 isn't a very even number to count up by and find multiples of. So instead, what we're going to do is round that up to an even 3. And that's how we'll number our bottom axis. We'll start with 0, and then we'll go up by 3, 6, 9, and so forth, all the way up to 30. The reason we did that is that then our highest number on our axis should be very close and not less than our highest number in our data. And that means that we're not going to have a bunch of blank space on the graph, because our data is going to fit that axis very nicely. We'll then repeat that process for the other axis, which I'll do right now. So the largest number on the free throw percentages is 90. And there are also 10 spaces on the left side of this graph. So 90 divided by 10 is 9. Though 9 is an even number, counting up by tens is very easy. And so I'm going to round that to 10 before I number my axes by tens for the intervals. And so after I do that, then I'm actually ready to plot these data points, which were plotted already. but just like this first data point has a number of game played of 3 and a free throw percentage of 40, which corresponds to this first row of data up here. And that first row of data corresponds to Jessica right here. So each data point we're looking at, the number of games played, and because we've labeled that bottom axis, then we know which axis to use for each column in our data table. You can take a look at that finished graph. And we'll go on to the next problem. Here we have temperature and number of sales at a food truck. And so because the number of sales is the thing that gets affected by the temperature, we're going to treat temperature as our independent variable and the number of sales as our dependent. Once again, you'll notice that the independent variable, which is on the left side of the data table, that goes to the bottom of the graph. And then what's on the right side of the data table goes to the side of the graph. And that's always the case every single time. We put our title. Our title is the effect of temperature, the independent variable, on number of sales, the dependent variable. We decided that our axes were where they are, and then we picked our intervals with the exact same process that I described in the last graph. Starting by identifying the largest number in each part of our data, then dividing by the number of spaces, and rounding up if we have to before numbering from 0 up by whatever that rounded value is. So in both cases, that rounded value is 3. And then after the title and the axes labels are there, the intervals are numbered, then we can start plotting data points. For this next problem, it's quite different. Here we have a finished graph, and what we're trying to do is construct a data table based on this graph. So the hours of sunlight exposure, since it's on the bottom of the graph, is going to be the independent variable, which makes it the left side of our data table. And then the thing on the side of the graph has to be our dependent variable, which will make it go on the right side of our data table. And so we'll see that temperature is the dependent. Then what we can do is on this graph, we can just place data points at each of kind of these intersections or these ends of these line segments. And then we can read what those data points are based on where they fall on the x-axis and where they fall on the y-axis, or how many hours they correspond to and how many degrees. So this first data point right here has 0 hours of sunlight exposure and 0 degrees Celsius. The second data point now has 1 hour of sunlight exposure if we look at where it is on the x-axis, and it has just less than 14 degrees Celsius. So we can estimate that to be about 13 degrees. Our next data point right here is at 2 hours of sunlight exposure and more than 14. It's also farther away from 14 than the last data point. So we can estimate that to be about 16 as far as temperature. And then we just repeat this process for 3, 4, and 5 hours of sunlight exposure. And drawing straight lines down to the x-axis and over to the y-axis to see what values that data point corresponds with. The first question after this data table says, what is the graph above measuring? And it's measuring the temperature of a greenhouse after a certain number of hours. Then it asks us to estimate the temperature of the greenhouse at 3.5 hours. And so even though a measurement wasn't necessarily made at this point, we can find 3.5 hours on the x-axis, right between 3 and 4. And then we can draw a line up to see where a data point would be at 3.5 hours, and then draw a line over to the y-axis to determine what temperature might that data point correspond with. So it has to be more than 21, less than 28. And so a good estimate would be around 23 degrees Celsius. On this next problem, it's very similar. We'll just be reading data points from multiple different lines, and so we have to use this key at the top in order to determine which line corresponds with which type of mineral or rock. So the first one, rock salt, we're looking for this large dashed line. And so the large dashed line is the top line in our graph. And so we're looking to take a measurement at every 100 degrees Celsius, because that's what's in our data table, 0, 1, 100, and 200 degrees Celsius. So we can put a data point right where they cross these vertical lines that correspond with the temperature intervals. And then at each data point, we can estimate what kind of thermal conductivity that corresponds to. So the first one is just over 6. Let's say 6.2. This next one is just over 4. So we can say 4.2. The next one is just over 3. And it seems closer to 3 than the last 2 points were closer to their closest whole thermal conductivities. This data point is right between 2 and 3. So 2.6 or 2.5. And then the last data point is very close to 2. So we then repeat this process with the next type of rock, granite. And so we would make data points along the lines, and we'd read where those data points are on the y-axis. And we'd be able to make estimates for what those thermal conductivities are, and then repeat for basalt and shale. Generally speaking, as temperature increases, what happens to thermal conductivity? So as we're looking at all of these graphs, as the temperature goes, as it increases, we're moving from the left side of the graph to the right side of the graph. And so then we're asking what happens to this variable when we look at the data on the left compared to the right. And generally the trend is down, meaning that thermal conductivity must be decreasing. The second question says, do any of the materials not follow the general pattern? Which ones? And if we're looking at these graphs, there's one line that doesn't actually decrease, it increases, and that would be this solid line. It actually goes up instead of down. And so then looking at our key, the solid line is basalt. For this last problem, we're going to create a very involved graph because we've got lots of data to put on the same graph. So first, we're going to write a title. For our title, we need to know what the independent and dependent variables are. So the independent variable is in this first column. And then the dependent variable is actually all of these things. And so instead of writing down the size of the pea plant or the size of the tomato plant, I'm going to try to summarize all three of these columns as just the size of plant. Because then we can be specific about what type of plants they are later on in our graph creation. So I've written a title, the effect of age on plant size. Now we have to decide which axis each variable is going to go on. So since age is my independent variable, or since number of days old, I'm going to put that on the bottom of my graph. And then because size of plant is my dependent variable, I'm going to put that on the side of my graph. Then we need to figure out what the intervals are going to be on each axis here. So to do that, I need to figure out what the largest number is for each of these axes. So I'll start with the bottom axis for the number of days. The largest number in that data is 25. And so I'm going to write down 25. And now I have to count how many spaces there are on this side of the graph. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So there are 20 spaces on the bottom of my graph. (25) divided by 20 is 1.25. And since I don't know how to count up by 1.25s very easily, I'm going to round this up to 2, because that's a whole number that I feel confident in counting up by. So then I can go ahead and label the intervals on the bottom, starting at 0 and then going up by 2. Now I'll repeat the same process for the other axis, and I'm not going to show you that entire thing. I'll just write down the calculations in the bottom and then number the intervals. So for this y-axis, or the dependent variable, I found the largest data point in all of these columns. The largest data point is 14.3. And so then I took that 14.3 and I divided by the number of spaces on the left side, which is 15. I got 0.95, and so then I rounded that to an even 1. So then I could number my axis, going up by 1s, all the way up to 15. And now the last thing I have to do is make sure that my labels on my axes are sufficient. The number of days old already has a unit of measure in it, but my size of plant doesn't have a unit yet. So I have to go up here and look at my table. And since the size of plants is measured in centimeters, I'm going to go and add that to my label of my dependent variable axis before I can start plotting points. For the first set of points, I'm looking at pea plant. And so at 0 days, the pea plant was 0 centimeters tall. At 5 days, it was 1.2 centimeters tall. So I'm going to start by going over to 5 days on the number of days axis, and then I'm going to go up to 1.2, and I'll have to estimate where 1.2 is to make my data point over here. My next row of data is at 10 days and 4 centimeters. So 10 is actually a line on my x-axis, and 4 centimeters is also a line, so I'll know exactly where to put this data point, right at the intersection of 10 days and 4 centimeters. Next, I can look at 15 days and 5.9 centimeters. So 15 is going to be right between 14 and 16, and 5.9 is going to be right before 6, not quite on 6. So the intersection of these points would be right about there. 2 more data points at 20 days and 9.3 centimeters. So 20 days will be on a line, and then 9.3 should be above 9, but not quite halfway between 9 and 10. So this is getting a little bit far away. I'm going to draw a dotted line until I get to 20 days, and then I'll make my data point right there. Ooh. Last data point is 25 and 10.2. Apologize for the bell. So that's my last data point for the pea plant. And now what I'm going to do is I'm going to repeat the entire process for my tomato plant. But as I do this, I'm going to use a new color, and that's because as I start plotting points for the tomato plant, I don't want to get them confused with the points that I already plotted for the pea plant. So at this point, I have plotted all of the data points for the tomato plant. And now because I have 2 different colored data points on my graph, I want to make sure that I can tell the difference of them. So I'm going to make a key down here in the bottom corner. And so I'll say that any data point that's orange like this belongs to a tomato data point, and then any green point belongs to a pea plant. My last data is going to be for beans. And so if you don't have different colored pencils, or if you're not using your Chromebook to make a graph, then another way that we can accomplish this is just by making our data points different shapes. So I'm actually going to make my bean data points the same color as my pea, but they're going to be squares instead of circles, just so that I can show you how we can make our data look different, even if we're using the same color. And so with those bean points plotted, you can see that even though they're the same color as the pea points are circles, and then the bean points are squares. And so even if you just have one writing utensil as you're making a graph, being deliberate and having a key with different colors or different shapes for each data set will help us to keep them separate as we're looking at a very complex graph like this one. Thank you very much for watching.